And yeah, welcome. This will be about microfrontends and module federation, which will become quite a revolution if you ask me. But first of all, let me start with a question. Who remembers those three guys? Perhaps you remember them. They are from an 80s TV show called Riptide. And I really had to think back about them when I prepared for this presentation. And when I did so, I found out several things that are somehow funny. First of all, this is not Tom Selleck. So for my whole life, I have to admit, I thought that this was Tom Selleck, who I saw in the 80s in this TV show, but he isn't. I don't know why I have confused those two people. Another thing is, I did not even remember the term Riptide because the German name of this TV show was not Riptide, it was Trio mit vier Fäusten, which means something like trio with four fists. Just four fists, even though we have three guys here, but this guy here was not using his fists, this guy here was using his brain. He was the general purpose computer scientists in this team. And the funny thing is, when thinking back about this is, I noticed that this guy was a one-man show. And perhaps that was possible in an 80s TV show. But nowadays, this is not possible. Nowadays, computer science or software engineering is not a one-man show. Nowadays, software engineering is a team sport, isn't it? We need to have several skills. We need to have a diverse team, and they have to bring their skills together. And coordinating one team is hard enough. But the truth is that nowadays, we very often have several teams to coordinate because software is that huge and that complex that we need several teams. And this is even harder than just coordinating one team. And so a lot of people thought about how can we make this a bit easier. And one solution that comes in mind is not creating monoliths. A monolith in this sense is a big application that can do everything, that can cook your coffee and that can book your flights and that can sort your socks, something like this. No, this is not a good idea. Instead of this, the idea is to create microservices. Microservices like a booking service or a check-in service or a luggage service or a boarding service instead of our huge overall flight management system. The idea is to separate those services, to isolate those services from each other. The lesser they know from each other, the better it is. Because if they don't know much from each other, you can easily change something there without breaking something here. This is a big issue with monoliths. You try to maintain it, you try to change something, perhaps you just try to fix a bug, and by fixing a bug, you damage a whole other part of the story. This is prevented by loosely coupling those services. Well, the term microservices is here for about, let's say, 5 years. The idea behind it is much older, I would say at least 20 years. And as microservices are quite popular nowadays, people think about how to transfer this idea into the world of frontends. And what comes out when doing this is called microfrontends nowadays, which is quite a new term, but at the end of the day, it's the same idea. Having small applications instead of one big monolithic application and decouple those applications from each other. This is the main idea here. Why is this beneficial? Well, if I have micro apps, micro frontends, I can use autonomous teams. I can have one small team for the booking app and one small team for the check-in app and further teams for the other apps. And most importantly, they don't need to coordinate that much with each other. They can just do their job. They can just work on their part without interacting much with the others. And this brings back a lot of agility. That means even in a huge company, you can have the agility of a startup because you have these tiny isolated themes. And that shows one thing that's very important here. Micro frontends as well as microservices are first and foremost about scaling themes. They are not about technology. They are not about fancy frameworks. No, they are about a very unemotional topic like sharing, no, not sharing, like scaling themes. You just want to scale up your process for software development. And that means you will most likely benefit from this style of programming if you have more than one theme, because themes is plural, you know, and that means having more than one. If you just have one theme, then perhaps this is not that beneficial for you. Then perhaps this comes with more overhead and disadvantages than with advantages. So the thing is that we are questioning ourselves, that we are wondering how to implement such micro frontends for years, because there was not a sound solution for this. There have been several approaches, but there was not this one and only sound solution. But this changes now with module federation. Module federation will be baked into Webpack, and so it will also be available for the Angular CLI, which is nowadays using Webpack underneath. And so we have finally something like an official solution that has been thought through by a bigger team like the Webpack team. And this is what this presentation is about. In this presentation, I will show you how to use module federation. First of all, I will start with an overview of module federation. I've brought an example for it, and I will show how to use it together with Angular. Then I will give you a roadmap, because the first question is, when can we have it? And of course, there is not a perfect answer to this question, because it depends on several things, but I can give you some indicators. And then I have a little nice, hopefully funny challenge for you to try out, to encourage you to try out module federation. But first of all, let me introduce myself. I am Manfred. I am a trainer and consultant for Angular. I'm helping a lot of companies with Angular workshops and consultancy in the last time, because of the current situation, of course, remotely. But when we don't have a pandemic, I'm also doing a lot of in-house stuff. And besides this, I'm quite connected to the Angular community, and I really love Angular. Also, I'm doing a lot of stuff in the German-speaking area, but sometimes if I promise to behave well, I'm also allowed to work with other companies in other countries, which is quite nice and quite simple nowadays, because, as mentioned, we are doing most of our works those days remotely. Okay, so let's get started with the first chapter of this presentation. Let's get started with an overview of module federation. And I'm always saying module federation is a bit like the 1980s. You have to experience them to know what they are about. And so I would say, let's get started with a demonstration. In this demonstration, I have a simple shell. A shell is just an application which is capable of loading other applications. And this happens when I'm clicking here. When I'm clicking here, I'm directly loading a separated compiled, a separately deployed application into my shell. And so it appears here within the dashed lines. To prove that this application is a separately compiled application and a separately deployed application, I have here the same application which runs in standalone mode. That means we can decide upon using it as a standalone thingy or using it as part of our bigger shell. So let's have a look under the covers. Let's find out what happens when we click this flights link here. For this, let me open the developer tools, and here we find the network tab, and now let me click flights. And what you see here is that a lazy chunk is loaded, and this lazy chunk only has 3 dot something case, which is quite slim. It's quite slim, and this clearly shows that it is not containing Angular or some other frameworks. It is only containing my very own code. That means even though it has been compiled separately, it is reusing Angular core, Angular common, and so on from the shell. The shell is sharing it with this remote application. Perhaps you are saying now, yeah, that looks nice, but we already have this for years because this is just lazy loading. And I'm saying, no, this is not just lazy loading, because if you look here we have localhost 5000. And if you look there we have localhost 3000. So it is a completely different origin where I find this chunk, and I'm just loading it from this origin into my application. Those two chunks did not know each other at all when compiling them. They just meet for the first time at runtime, which gives me a lot of flexibility. For instance, one autonomous team can just publish its part when they are ready. And then my shell will always load the newest part, or let's say a configured part, into this very application. The teams can work individually and decoupled from each other. Okay, so now the next question is how to load separately compiled code into a shell. And perhaps you're saying, hey, this cannot be that difficult because, you know, nowadays we have dynamic imports, and before we had the require statement when we used Webpack or even Node.js. So this cannot be that difficult. But as a matter of fact, when we are using Webpack nowadays, and so when we are using the CLI, it is difficult because Webpack is not allowing to do something like this. Webpack does not allow us to load something from a different origin at runtime. And the reason is that Webpack assumes that everything is known at compile time. Even the lazy parts of your application have to be known at compile time, because Webpack is compiling everything, Webpack is optimizing everything, tree shaking takes happen, and then and only then Webpack will split your whole source code into chunks that might be lazy loaded during runtime, but only after the compilation and after the optimization. And so in the past, it was really difficult to load something from another origin. But here, this is the goal, isn't it? So the good message is Webpack 5 module federation allows for this. And for this, we have on the one side a shell. Module federation is calling it a host. And on the other side, we have a microfrontend, a separately compiled microfrontend, which is called remote with terms of module federation. And besides this, within the shell, we can map URLs. Here I'm saying, hey, the URL mfe1 is not something that points to internal code, it points to external code, to code that has been published separately. And you see I'm mapping mfe1 to mfe1. This is done because module federation allows me to define aliases. I could define an alias called Manfred, which is pointing to the microfrontend mfe1. So this is a general idea. It is normally a good idea. Try to name as many variables Manfred as you can. It will for sure make your software more appealing. Well, besides this, here I'm not using aliases. That's why I'm mapping one name to the same name. Besides this, on the other side, within the microfrontend, I can expose several files. For instance, I'm saying I'm exposing this file with this very component under the name CMB. That means this component can be separately loaded by the host. And then something beautiful happens. I can use an import statement like this. And as you see here, the import statement imports something from MFE1. And now, of course, this MFE1 points to my mapping within the Webpack configuration. And besides this, this mapping points to the micro frontend on this or on that origin. And as this micro frontend exposes something under the name CMB, I can load this very file with this import here. So importing something that has been deployed separately is really a piece of cake with module federation. Perhaps you're wondering how the shell gets the URL from the micro frontend. Well, the thing is, when compiling the micro frontend, Webpack gives us a remote entry point, which is just a tiny file, just several bytes, nothing more. And then I can load this remote entry point into my shell. I have to do this nowadays with a script tag, but the script tag could also be a dynamic script tag. I could create it with vanilla JS with DOM manipulations. Hopefully, in some of the further releases, in one of the upcoming releases, we can just tell Webpack to load this or that entry point, or we could just perhaps configure Webpack, tell Webpack that this or that location is the location of the micro frontend 1, of the micro frontend 2, and so on and so forth. But for the time being, we need this script tag here. And after loading the remote entry point, the shell knows where to find this very remote, this very micro frontend. Now you perhaps say, well, that's nice, but somehow we need to prevent that we load Angular twice or 5 times if we have several micro frontends. Because when compiling those micro frontends in a traditional way, of course, they get their own copy, at least their own parts of Angular. And this is also solved by module federation. Module federation allows us to share dependencies. For this, just use this shared array, which is also part of the Webpack configuration. Within this array, you can put all the libraries you want to share, which is Angular core within the shell, which could also be Angular core within the micro frontend. And if both need the same dependency, and if this dependency is part of this shared array on both sides, the micro frontend will just reuse the already loaded Angular core library from the shell. And that's why, in my case, the loaded micro frontend was that tiny. You remember it just had 3Ks, which is nothing more or less. Of course, now you are saying perhaps we can have conflicting shared libraries. Perhaps the host is loading Angular 7 and the micro frontend needs Angular 9. And this can be a real showstopper. And guess what? You are right. It can really be a showstopper. Saying this, module federation comes with 2 solutions for this. First of all, we can say, even if we get the wrong version, we reuse it anyway. Just trust into your luck. Perhaps you are lucky and everything works as expected. If you have bad luck, of course, it won't work. If you are expecting Angular 9 and the host only gives you Angular 7, perhaps your application is completely blown up. And the second option is the micro frontend could decide on runtime to load its own copy of Angular, which is also not the best idea when it comes to Angular. If bundle size is not a big issue, loading a tiny library like RxJS twice could be okayish. You have it once in this version for the shell and once in that version for the micro frontend. But in general, it is not the best idea you can come up with. And saying this, it seems like that both options might be bad. Of course, it always depends on your very situation, but both options might be bad. And so, as it turns out, it is possible that we need to prevent this situation by ourselves. by introducing conventions, by introducing contracts, or by using a mono repository, which can also help here because it forces you to use one version of all your libraries. Of course, when it comes to separate deployment, we can have different versions over time, but it is better than nothing if you use a mono repo to prevent this very situation. Also, using E2E tests, integration tests, can make sure that everything works at runtime when the separately compiled parts meet each other. And perhaps this is the biggest issue with microfrontends. It is an unsolved issue. Perhaps it is not only an unsolved issue, but also an unsolvable issue. And that means you have to prevent it by yourself, as mentioned before. Or perhaps you are just putting your head into the sand and hope for the best. Could also be a solution, but I don't think so. So let me show you a demonstration for this. When we look into this demonstration, you see first of all a routing file. It's called approots. It's part of the shell. And as you see here, my shell is just using lazy loading. It is just using default Angular stuff, the router itself with load children to load this microfrontend. But the thing is that here I've mapped MFE1 to a microfrontend which was separately deployed. That means at runtime, Webpack will find out that I don't want to load internal stuff, but external stuff. To be more precise, I want to load the exposed module over there. If we have a look into the Webpack configuration for the shell, we will see that I'm just telling the shell, hey, I will use the URL mfe1. It points to an external microfrontend, and it is also called mfe1 over there. So I'm not defining aliases. Besides this, I'm sharing some libraries like Angular Core, Angular Common, the router, and so on. This is the configuration for the shell. It's really simple, isn't it? The rest of this Webpack configuration is normally produced by the Angular CLI, but more about this later. If I scroll down, we see the configuration for the microfrontend. It's slightly bigger. The microfrontend has a name, mfe1. I'm defining a name for the remote entry point. I'm exposing several files like a module with some child roots, a standalone component, and I'm also defining that I want to share Angular Core, Common, and the router itself. And that's it. Now we just need to compile everything with Webpack to build everything, and then the shell can load the separately compiled remote, the separately compiled microfrontend. Well, there's one more thing you need to take care about, namely this remote entry point. This remote entry point has to be loaded into the shell. That was the wrong index.ts. Here we go. It has to be loaded into the shell because by loading this remote entry point, Webpack gets informed about where to find mfe1, where to find this very microfrontend. And as mentioned, hopefully we will get something like this, a function which allows us to configure Webpack instead of the need to load this remote entry point. Honestly, I've even already seen a pull request, a commit for this very repository, which is solving this, which is introducing a method like this. So hopefully we will get it in one of the next versions. Okay. So now, of course, your question is, when can we get it? Which is the roadmap? How does the roadmap look like for this? And well, what I'm telling you now is totally unofficial. And the source for this is my very own coffee grounds reading. So don't do much bets on this. But what I can tell you is that Webpack 5 is currently in beta. And I can also tell you that the example I've shown you is just a proof of concept using a custom Webpack configuration and a batched version of the CLI. And I assume you don't want to use neither. You don't want to use a custom Webpack configuration. We did this 5 years ago and it was not that funny. And you don't want to use a patched version of the CLI. For sure, you want to have an official CLI version. Saying this, the CLI will for sure not support Webpack 5 before version 11. Because version 10 is more or less ready. I think we will see it in several weeks, perhaps, because I mean, look at the calendar, and we have this release cycle, this 6 month release cycle, and so the next chance to squeeze Webpack 5 into the CLI is fall 2020. Then version 11 comes out. And this is only possible if Webpack 5 is ready then. Rumor says it should be ready so that we can squeeze it into version 11. And then you somehow need to squeeze in the module federation config into the CLI's config. You don't want to do this by hand. That means we need a custom builder, which is quite nice because the Angular CLI is extensible in so many ways. And we could just use a custom builder to take this tiny module federation config and squeeze it into the Webpack config produced by the CLI. For instance, you could use something like ngx build plus nowadays. This is a builder I wrote, which is just doing what I just mentioned. Yeah, and then it's ready to be used together with Angular. If you like this presentation, you will perhaps also like, by the way, my ebook. It contains a lot of stuff about module federation, also about alternatives. Because software architecture, you know, is always about alternatives. You can download it here at angulararchitects.io/book. So we are reaching the end now, but before we are reaching the end, I have a little tiny challenge for you. This little tiny challenge is about Snake. I guess you know this computer game, which is called Snake. There is a very nice open source implementation created by this smart guy here, which is called ngx Snake, and as the name tells us, it is using Angular. So let's have a look at this Snake game. Here we go. I'm saying start game, no balls. And as you see here, my snake is randomly moving around. So you see, I'm not using my fingers on my keyboard. It is just randomly moving around. Why is that? Well, I've taken this open source implementation and I patched it. I squeezed module federation into it so that it allows to load a remote which is controlling the snake. Currently, I'm using my own implementation for the snake service, which is just a simple implementation sending around the snake randomly. Saying this, please do never ever load a foreign stuff, a foreign module container into your application in real world. For this example, it is okay because this is not a critical application, but in real world, only load trusted parts, trusted plugins into your application. So here I'm loading my snake strategy into my application, and this makes the snake move around. And now I have a challenge for you. This challenge is about implementing your own strategy for moving the snake around. A better strategy, a smarter strategy than my random strategy. And then publish it using module federation. Publish it as a remote. We will have an award ceremony on the next NG Copenhagen online meetup. In this award ceremony, we will load your implementations into our snake game, and then we will find out which implementation does best, which implementation will do the most points, which snake will eat the most fruits in a given amount of time. And yeah, if you want to take part in this challenge, you find all the material, everything you need, a detailed README under this location here in my GitHub account. Just check it out, play around with it, publish your strategy, and let's find out if your strategy is better than the other ones. Okay, so let's come to a conclusion. We have seen the main purpose of micro frontends is not technology. It is not about frameworks. It is not about being one of the cool people. It is just about scaling teams. This is why we invented this very concept. And that means you need more than one team to benefit from it. We have also seen that federation, module federation, is about importing stuff from another application. Importing something that has been separately compiled. This is also about sharing libraries. It's a beautiful feature. Module federation allows you to share libraries between the host and your remotes. And please take care of conflicts. This is something I think we cannot easily take care of with technical means. You have to take care of this by yourself by introducing some conventions and some best practices. And there is one last thing, please think about this, namely, please try to be a bit like Murray. Murray was the computer scientist in this RipType team, because Murray is one who does not hit, who does not strike. He always thinks. He was not one of the guys using his fists. He was the guy using his brain. What do I mean with that? I mean with that, please first of all evaluate if you need micro frontends. And if you say, no, I don't need it, then go with a monolith. Some people are calling it a majestic monolith. If it is a monolith which is done very nicely, you can use something like an X for this. And if you say, yes, we need this because we are a huge company, we have several teams with different knowledge, then please consider module federation. I think it will really be a game changer for this kind of architectures. So thanks for having me. Here you have my contact data. You find all my material, my slides, my example in my blog. And if you want, follow me on Twitter so that we can keep a bit in contact. Thanks for having me and have a nice day.